Good morning students. Today we are going to see the electrochemistry. In this lesson we are going to see the Nernst equation. What is Nernst equation? It is used to find the EMF value of the cell, that is electrode potential. Consider equation Mn plus, that means Na2 plus Cu2 plus, like that, accept two electrons to form a metal. Then EMF of the cell is equal to E naught. This E naught is the standard electrode potential. Standard electrode potential. Standard electrode potential. So this is the electrode potential. This is standard, not mentioned as standard. Standard electrode potential minus RT by NF. This equation we are going to derive. This is the Nernst equation. Nernst equation which relates the potential and the concentration of the species. This is the potential, EMF electrode potential, and the concentration of the species involved in the electrochemical reaction. Involved in the electrochemical reaction. So now we are going to see the equation. Consider a general reaction, that is XA plus YB, reversible reaction LC plus MD. This is the X, Y, L, M are the coefficient, and Q means under non-equilibrium condition. Q means under non-equilibrium condition. So under non-equilibrium condition we are going to find that is concentration term constant Q, and delta G is equal to delta G naught plus RT ln Q. This is from this we can learn from the 1/2 equation. So delta G is equal to delta G naught plus RT ln Q. This equation also we know, that is delta G is equal to minus NF E naught from thermodynamics. So instead of delta G we are going to substitute the NF E naught. NF E here minus NF E naught plus RT ln Q we are going to substitute in terms of concentration. Divide this whole equation by NF minus NF. So divide this, cancelled, here NF ln C concentration, product by reactant, and now E is equal to, remaining E is equal to E naught plus, here one minus is there, no, so minus RT by NF ln this one. Ln is equal to 2.303 log to the base 10, and instead of ln we are going to substitute the log. E is equal to E naught minus RT by NF, that is 2.303 log to the base 10, concentration of C power L, D power M, A power X, B power Y. So E is equal to E naught minus, write this term, constant term this side, 2.303 RT by NF log to the base 10, this concentration term. This equation is called as a Nernst equation. At 25 degrees Celsius, this, that is 25 degrees Celsius means in Kelvin it is 273 plus 25, 298 Kelvin. The above equation becomes E is equal to E naught cell minus 2.303 RT by NF log concentration term. Substitute this R, F and T values. R constant, gas constant, Faraday constant 96,500 coulombs, T temperature 25 degrees Celsius. While substituting all these values, this equation becomes EMF of the cell is equal to E naught of the cell minus 2.303 into 8.314 into 298 by N into 96,500. These all are the constant term. 2.303 we derived from the log of this value. So if you substitute all these values here, we can get the 0.0591. EMF of the cell is equal to E naught of the cell minus 0.0591 by N log to this. And now this concentration term is 25 degrees Celsius means it is constant value, no? So EMF of the cell is equal to E naught of the cell minus 0.0591 by N log K. 591 log K. This is the Nernst equation. This we are going to substitute in the problem for finding the EMF of the cell. Let us see one problem, that is, let us calculate the EMF of the following cell at 25 degrees Celsius using Nernst equation. So Cu var Cu2 plus means this is Cu is converted to Cu2 plus, oxidation takes place in 1/2 cell. This overall is called as a full cell reaction. This is 1/2 cell, this is 1/2 cell. One is oxidized, another one is reduced. Fe3 plus to Fe2 plus reduced. So this oxidation and reduction both takes place in a single cell is called as the redox reaction. So the EMF of a different half cell is given, that is E naught of Fe3 plus bar Fe2 plus is 0.77 and this another half cell is 0.34. We are going to write this separate as a separate equation, that is Cu Cu2 plus. Cus is converted to Cu2 plus. How many electron is transferred? 2 electron. Fe3 plus is converted to Fe2 plus. Fe3 plus is converted to Fe2 plus. And if here 2 electron mean here also 2 electron, no, balanced. 6 plus 2 minus remaining 4 plus. So this is 2 2s are 4, 3 2s are 6. The overall reaction we have to add this. For this overall reaction we have to add Cu solid 2 Fe3 plus 2 electron. Add reactant side one side and the product side another side. So this 2 electrons and 2 electron get cancelled. We get the remaining. Formula, Nernst equation formula we have to use at 25 degrees Celsius. EMF of the cell is equal to E naught of the cell plus 0.0591 by N log K. N is equal to 2. Why it is 2? Cu2 plus is converted to 2, no? Here only how many electrons are transferred? 2 electrons are transferred. Since the 2 electrons are transferred, this is the N. N is the number of electrons transferred. So K is equal to, what is this K formula? Equilibrium constant, product concentration by reactant concentration. Product concentration by reactant concentration. In the Nernst equation, the solid concentration, the pure solid and the pure liquid concentration is equal to 1. Pure solid and the pure liquid concentration is equal to 1. So this is ion, this is ion and this is a pure solid, no? So this concentration is equal to 1. So now the K is equal to Cu2 plus. Ions only depend on the equilibrium, no? So the solid and the liquid are constant. So remaining is this. So in Nernst equation we can write this as EMF of the cell is equal to E naught of the cell minus 0.0591 by 2. N is equal to 2, no? So 2 log of Cu2 plus Fe2 plus by Fe3 plus square. 2 moles, no? So square. Normally how will you calculate the EMF of the cell? So E naught of the cell is equal to cathode minus anode. Cathode means reduction takes place, anode means oxidation takes place. Its value is given. So directly substitute these values and find the, this is V, volt. And E naught of the cell is equal to 0.43 volt. E naught of the cell is equal to 0.43 volt. So now E naught of the cell is EMF of the cell. We are going to calculate the EMF of the cell. So EMF of the cell is equal to E naught of the cell minus 0.0591 by 2 log of Cu2 plus Fe2 plus by Fe3 plus square. Fe, this is also square by Fe3 plus square. Substitute this all these concentration values. Where the concentration values? It is given inside the bracket of this ions in the problem. So the Cu2 plus its concentration is 0.25. Fe3 plus concentration is 0.1. Fe2 plus. Fe3 plus concentration is 0.005. Now substitute all these. The 0.1 can also be written as 0.01. So 0.43 minus 0.0591 by 2 log of 0.25 into 10 power minus 2. This is nothing but 10 power minus 2, no? This is 10 power minus 4 into 0.25. 5 5s are 25, no? So 0.25 20 square 4. So this is equal to 0.43 minus 0.0591 by 2 log of 10 power minus 2 by 10 power minus 4. This becomes plus 4, minus 2 and plus 4, that is 10 power minus 2 into 10 power plus 4. Remaining is 10 power 2. So this is the 10 power 2. So this is equal to 0.43 minus 0.0591 by 2 into log 2 10 power 2. This can written here. So it becomes 2 log 10. Log 10 value is equal to 1. So 2 we are writing. Cancel these 2. Now we can write the subtracting this from this means we get this value. So EMF of the cell is equal to 0.3709. So this is in this way we have to calculate the EMF of the cell. So the Nernst equation is, what is the Nernst equation? E is equal to E naught minus, that is EMF of the cell is equal to E naught, that is standard electrode potential, minus 0.0591 by N. What is that N represents? Number of electron transferred between the reactant and the product side. And what is that next term? Log to the, that is 0.0591 by n log to the base 10 product concentration by reactant concentration. In this problem, if the solid and the liquid concentration is there, means its concentration is considered to be unity. In the next, we are going to see the book back, which is related with the Nernst equation. That is question number 5. Calculate the EMF and write the Nernst equation for the following cell at 298 Kelvin. That is, we are going to calculate the EMF using the Nernst equation. Here, 4 problems are given. First 2 subdivision, let us discuss. Remaining 2 is homework. You have to do that. What is given in the first equation? First we have to understand Mg2 plus. That means this is the overall cell reaction, no? This double straight line called this a salt bridge. Double vertical line is called as a salt bridge. Double vertical line is called as a salt bridge. That means which separates the one half cell from another half cell. What is this double straight line called as? A salt bridge which separates one half cell from another half cell, and this single vertical line is called as a phase boundary. What is this phase boundary represents? This phase boundary means it has a tendency to separate the metal and its ionic solutions. That is metal and its ionic solutions. So this single vertical line means phase boundary, which has a tendency to separate the single, that is salt bridge, that is metal electrode and the ionic solution. Salt bridge means which separates the two half cells. So this is the, what is this? Mg is converted to Mg2 plus, one half cell. This is the oxidation reaction. Electron is removed now, and the Mg2 plus concentration is this one. In the bracket we have given the, given as salt bridge. Before going to that, ionic concentration. Here Cu2 plus is ion aqueous solution. That means aqueous solution means it is in the solution form, no? So its concentration, you have to write the concentration. This solution is separated from the metal electrode by the single vertical line, and this is Cu solid. Now this is our problem. From this we are going to find the EMF of the cell using the Nernst equation. And one more given detail is E0 of Mg2 plus is this one, and Cu2 plus Cu is this one. So the details are given. This is oxidation and this is reduction. Oxidation and reduction. Yes, let's solve this problem. This is our cell reaction. Overall reaction you have to write, no? How will you write? How will you convert this into this? This Mg is converted to Mg2 plus. Yes, Mg is converted to Mg2 plus. What is this? Cu2 plus is converted to Cu2 plus. Cu2 plus is converted to Cu. Simply, what is in the first, you have to write in the reactant side. Another half cell, what is in the first? Write it in the reactant side. So Mg plus Cu2 plus gives. Second is written in the product side. Here also the second is written in the product side. Simple. We can able to make the simple chemical reaction. So from this equation only we can able to calculate the K equilibrium, no? So let's write. This is the overall reaction we finished. What is the N? N means number of electron transferred. How many electrons are transferred? Mg is converted to Mg2 plus. So the N value is 2. And now we have to find the overall E0 value. No, it is given separately for Mg2 plus and Cu2 plus Cu. So what is the formula? E0 of the cell is equal to E cathode minus anode. Cathode means in cathode always which reaction takes place? Reduction. What is reduction? Addition of electrons. What is oxidation? Removal of electrons. Removal of electrons. Yes. So this is addition of electron, removal of Mg2 plus, removal of electrons. So now this value is given and this value is also given. So we can able to calculate the E0 value, overall value of the E0. And now the E0 EMF of the cell is equal to E0 minus 0.059 by n log K. This is our Nernst equation formula. From this only we are going to calculate the EMF of the cell. So EMF of the cell is equal to E0 minus 0.0591 by n log, what is K? We have to write this from the overall reaction. What is the overall reaction? This is Mg2 plus product concentration by reactant concentration, no. Mg2 plus concentration, Cu concentration by Mg concentration, Cu2 plus concentration. Yes, Mg2 plus concentration, Cu concentration by Mg concentration, Cu2 plus concentration. We know pure solid and pure liquid solution is equal to 1 concentration. So EMF of the cell is equal to E naught of the cell minus pure solid, not aqueous solution, this is aqueous. So 0.0591 by N log Mg2 plus by Cu2 plus. These two values is equal to 1, no. Remaining Mg2 plus by Cu2 plus. So we have the concentration value given in the problem, no, as 0.001 and 0.0001. So this is we find 2.71 volt. We find from the two half cells, we find this reaction values. So EMF of the cell is equal to E naught value is 2.71, and this is a formula. N, what is N here? Number of electrons transferred. So this is 2. Log of Mg2 plus concentration is this one and Cu2 plus concentration is this one. And now we have to substitute in this. Now we have to substitute. What is that? 2.71 minus 0.0591 by 2. This is nothing but 10 power minus 3. This is nothing but 10 power 1, 2, 3, 4, no. So 10 power minus 4. After the decimal point, here is 1, 2, 0, 1, 3. So 10 power minus 3. If this minus 4, what is, how will you calculate this? 10 power minus 3 into 10 power minus 4 goes to the numerator, means it becomes plus 4. And plus 4 and minus 4 is 10 power 1. So that only we write like this is 10 power 1 directly. So 2.71 minus 0.0591 by 2 log 10 power 1. So this is equal to 2.71 minus 0.02955. And the EMF of the cell is equal to, while subtracting these two values, we get this. So this is the answer we find as a EMF. We find as a EMF. So what happened? One IUPAC equation. This equation is called as a IUPAC. IUPAC equation is given in our question. IUPAC is written in the ionic form. Two half cells are separated by a salt bridge, and one metal electrode and the ions are separated by a single vertical line. And along the aqueous solution, we have a concentration value, and solid, we know the value of concentration is equal. Solid does not change, no. So solid value is equal to 1. Solid value is always equal to 1. So what happens? First we had to write the single two half cell, then add, or if you can able to write it directly, means you can able to write it as the direct equations, overall reaction. And then first we had to find the EMF, E naught of the cell. What is the formula to find the E naught of the cell? E naught of the cell is equal to E naught of the cathode minus E naught of the anode. Cathode means which reaction takes place? Always anode oxidation, cathode reduction. Reduction means addition of electron. Oxidation means removal of electron. So then we can able to substitute these values and get E naught value. From this E naught value, we can able to calculate the EMF of the cell by using the Nernst equation. Let's see the next problem, Fe2 plus. First one is the reactant and second one is product. Keep it in mind. This electrode and ionic solution is separated by single vertical line. This aqueous solution concentration is 0.001. And H plus 1 molar concentration, H2 gas 1 bar. This is flat. What is this? Two straight lines are there, no? Here, this H2 cannot act as a electrode. This platinum is also used. This is called as a inert electrode. Platinum does not involve in the reaction, but it used to help. That means the H plus ions from the H2 get deposited on the platinum electrode and involve in the reaction. So inert electrode, this is called as a inert electrode. This is called as a inert electrode. So the value is EMF V naught value is 0.44. So Fe converted to Fe2 plus H plus to H. Fe2 plus means oxidation hydrogen. This is called SHE, standard hydrogen electrode. Standard hydrogen electrode. This standard hydrogen electrode, whether it is in the cathode side or anode side, its value is equal to 0. So from this we can able to calculate the EMF of the cell. First E naught value is Fe2 plus cell reaction Fe converted to Fe2 plus H plus to H2. This is oxidation and this is a reduction. What is this? Oxidation and this is a reduction. So what happens? Any reduction, whether this is called as the SHE, standard hydrogen electrode. The standard hydrogen electrode value is 0, that is EMF of SHE value is 0, whether it is a anode or cathode, whether it is a anode or cathode, whether it acts as a anode or acts as a cathode, its value is always 0, so that we can able to calculate the another half cell value, so that we can able to calculate the another half cell value. So the EMF E naught of the cell is equal to this SHE value is 0 and Fe2 plus is given, so we can write like this. E naught value is this one. E naught value we find now, then we can able to calculate the EMF of the cell. What is the EMF of the cell formula? This is our Nernst equation. EMF of the cell is equal to E naught minus 0.0591 by N log K. What is the K here? K you have to calculate Fe2 plus H2 by Fe solid and H plus square. This SHE value is always 0, no? So don't consider. Fe2 plus by Fe. Its value is 1, so 1 square. Fe2 plus concentration is given, so it is 10 power minus 3 and 0.44 value 0.0591 by 2 log 10 power minus 3. This power comes to this side, no? So 10 minus 3 into log 10. 0.44 plus 0.887. While adding these we get this one. This is the E naught value, that is EMF of the cell. So EMF of the cell we find. So what happens? We can able to calculate. Today we find we finished discussing the Nernst equation. Nernst equation means, what is Nernst equation? It is used to calculate the E naught of the cell and EMF of the cell. So from this we are going to find E naught EMF of the cell. EMF of the cell can be calculated only by the Nernst equation, and the E naught can be calculated using the cathode minus anode formula. Cathode minus anode formula.